Okay, so now that we have an idea of how covalent molecules, covalent compounds form compared to ionic ones, let's now take a look at the nomenclature of covalent compounds or molecular compounds. Okay, so again, nomenclature just means naming these things. So remember, we're looking at very simple cases of molecular compounds, which are binary ones that are just going to be made up of two different elements. So we're going to name the element that appears in the formula first. So that first element always gets a name. We're not going to do anything with the first name. The second element's name, we're going to change the ending to IDE. Okay. So for example, very simple case now, we have HCl. So HCl is made up of hydrogen. And then we have chlorine. What we're saying is the first element, we're going to keep it as it is. Second element, change the ending to IDE. So this is hydrogen chloride. Similarly, we have hydrogen. Then we have iodine. I in there, we're going to change the ending, replace it with IDE. So it becomes hydrogen iodide. Now, that's our starting point. The other thing that we're going to keep in mind now is that with our molecular compounds, our covalent compounds, we're going to start using what are known as prefixes to help us denote the exact number of atoms that we have of each element in our covalent unit in our discrete molecule. Okay, and we're going to use these Greek prefixes to tell us exactly how many we have. So we need to know these 1 through 10. I'll highlight this table. We want to know these prefixes. And prefixes by definition are things that go in front of the name. Okay, and we'll show you how to do these. So mono is 1, di is 2, and a couple of these you may have seen before, right? In just other lingo or other circumstances. So mono is 1, di is 2, tri is 3, tetra might be a new one, means 4, penta, like pentagon, is 5, hexa is 6. Hexa is the only one with an X in it, just like 6 has an X. Hepta is a tricky one, that's 7. Octa, like octopus, is 8. Nona has 2 N's in it, just like 9 does. And then deca, like decade, is 10. Okay, so there are different things to help you remember the prefixes. I don't really care what method you use. You need to remember these. They are very, very important. So let's take a look at how we incorporate them into the names for our compounds. And we'll take a look at a couple examples here to illustrate that point. So if I have CO, and then I have CO2, okay, we're going to name this. We're going to have the first name for the element, for the first element listed. So C is carbon in the first one. And the second one, we also have carbon there. Now, we said the prefix for 1 is mono, right? And we have 1 carbon in each of these cases. You can put your subscript in if it makes you visualize it better. The first element always gets a prefix unless there's one of the first element, right? So you may be tempted to write monocarbon, but if you only have one of the first element, okay, we can leave the mono out. So it's just carbon. The second element always gets a prefix, okay? So oxygen is the second element, okay? So oxygen, we're going to change the ending now, replace it with IDE, so this becomes oxide. We'll do this in a different color to show you how it changes. And now the second element always gets a prefix. So the prefix for 1 here is mono. Okay, when you have 2 vowels right next to each other, we drop the first one. Okay, so this then becomes carbon monoxide, not monooxide. So MON, so carbon monoxide. All right, and then in the case of the second one, again here, we have oxygen as the second element. Okay, we drop the ending, replace it with IDE. So again, this is going to have the same ending here, which is IDE. And now what's the prefix for 2? Well, it's di. Okay, so this is carbon dioxide. This is carbon monoxide. Very different things, right? This stuff here will kill you in small amounts. This one will not kill you in small amounts. You actually breathe that out all the time. All right, so those are the general rules. And as you probably have noticed, the naming your covalent compounds are going to be a lot easier than your ionic ones, as long as you know your prefixes. Okay, so if we take a look at another one, let's say we have S4Cl7. Okay, so we have the first element here is sulfur. So we don't do anything to the ending of the first element, it stays the same. We have four sulfurs, prefix for four is tetra. So tetrasulfur means four sulfurs. And then we have chlorine as a last name, that's chloride. Okay, we always change that ending for the second element. And seven now is hepta. Okay, so tetrasulfur, heptachloride. And the reason why I did this one as an example is because students often confuse the prefixes for 4 and 7. For whatever reason, they use tetra where, well, hepta should have been, and they use hepta where tetra should have been. So pay close attention to this. This is a very common mistake that I've seen, and it's not just, one semester. I see a lot of times over the course of several years. So pay close attention to those. So we've seen the systematic ways to name our covalent compounds. And just so that you know, because we'll see this term again, the systematic naming of compounds, systematic naming convention, this is known as the IUPAC system. Okay, and the system follows rules. There are rules that are involved in this. And this applies to both ionic and covalent naming, ionic and covalent nomenclature. So the IUPAC here is just the agency, I guess. It stands for the International Union of Pure and Applied Chemistry, right? They make up the rules that govern naming things. Okay, so up to this point, we've used all of the systematic naming rules so that when we name something, we know exactly what it means, whether you read it here in the United States or whether you read it over in England or in Australia or wherever. If you name it according to the rules, everybody knows exactly what you're talking about. Now, having said that, there are some compounds that go by common names instead of the systematic names. Okay, so for instance, if we look at our good friend H2O, okay, if you were to name this according to the systematic IUPAC naming system, H2O would be called dihydrogen monoxide. Okay, dihydrogen here meaning two hydrogens, monoxide meaning one oxygen. But we call it H2O. That's the common name for it, right? And in some cases, the common name is preferred just because we use it all the time. So H2O is an example, ammonia is another example, hydrogen sulfide. There are lots of these. We're not going to see a ton of them, but there are a few that we're going to see a lot of the times. Okay, another case where we are going to now take our names, our systematic names, and alter them a little bit is when we encounter our covalent compounds that contain hydrogen, specifically when we're dealing with acids. And acids are things that are able to produce hydrogen ions, which are H pluses when they are dissolved in water. And a good example of this would be hydrogen chloride. Okay, so HCl by itself, right, as the common name of hydrogen chloride, when it dissolves in water, it actually becomes an acid. So it dissolves in H2O. So it becomes an acid because what it does is it actually loses, it gives up this H plus. So it loses hydrogen as H plus, and that's what makes it an acid. Okay, so when it dissolves in water, we change the name. It becomes now not hydrogen chloride anymore. It becomes hydro. We drop the ending, and we combine it with this part here. So hydro and then clo. We drop this ending, replace it with ic, and then we have the word acid at the end. Okay, so that's the changes that are occurring um, when we name it as an acid that's dissolved in water. It goes from hydrogen chloride to hydrochloric acid. And in order for something to be an acid, again, it has to have an ionizable hydrogen atom. That just means that there needs to be an H that can be lost as an H plus. We'll talk more about acids and bases in the future chapters. So we talked about, hydrogen chloride becoming hydrochloric acid. We can apply that same naming system to lots of things. So hydrogen fluoride becomes hydrofluoric acid, hydrogen bromide becomes hydrobromic acid, hydrogen iodide becomes hydroiodic acid, etc.